So thank you, David, for letting me speak today. I'm actually Ringer McDonald. I'm on the faculty at Cal Poly San Luis Obispo. Since Roland mentioned it, I will tell you it's unfortunately very cold here today. It's about 65 degrees, but it's only 8:30 in the morning. So don't worry, it will warm up to like a comfortable 72 this afternoon. So, as David said, I lead the Cypher Education project, which is the education and outreach program of Psi4. And the reason that I asked David if I could talk here today is because I know that there are a lot of people who are new users who are attending today, people who haven't attended PsiCon before. So for those users, I really wanted to introduce you to Psi4, make sure you, or introduce you to Cypher Education, make sure you understood what we were about and what our purpose is. And then for our core developers who are with us today, I really wanted you to see the work that the Cypher Education team has been doing to promote and highlight Psi4 over the last year. So what is Psi4 really about? What is our mission? We really aim to provide outreach and education programming and resources to promote Psi4, increase its visibility and usage, and help develop partnerships with other entities that can help us with those goals. And when I say we want to promote Psi4's visibility, I don't really mean within the quantum chemistry community, because I think Psi4's visibility within the quantum chemistry community is quite well established. What Cypher Education really wants to do is increase the visibility of Psi4 to other people. Our real goal is that if you're a chemistry educator and you want to use computational chemistry to teach something in your class, we want Psi4 to be the first thing that you think of. And we want that to be true for people at all levels of higher education. If you're a faculty member at a community college and you teach chemistry there, or whether you're a faculty member who teaches at a small university that doesn't have a lot of computational resources, or whether you're a faculty member at a big state university like I am, who has to be able to implement anything I implement on the scale of thousands of students. So we want all of those groups of people to think of Psi4 as their first choice for including computational chemistry in their curriculum or using computational chemistry to teach something in their curriculum. So one very important way that we do that is that we try to offer resources. We call them our Cypher Education lab manual. So we try to offer these pre-prepared lab activities that use Psi4 that hopefully, if you don't know where to begin, you can just jump in with one of our pre-planned activities. Or maybe you look at our activities and it's not quite what you want, but it sparks your interest and it shows you how you could use Psi4 to accomplish your goals. And some people, are introduced to Cypher Education and then develop, very extensive curriculum for their particular program. And I think Francesco is going to talk about some of the curriculum he's developed for his program after me today. So be sure to be on the lookout for that. Another very important part of what we do is that we strongly promote Cypher NumPy. Because that is a very unique feature that Psi4 has that is very valuable to the educational community. Daniel Smith, who's been mentioned several times today, who is, of course, the original Cypher NumPy developer, he and I had an interesting interaction at ACS last year where he was like, Ashley, so-and-so came up to me and they asked me about this new Cypher NumPy thing, and I asked them how they'd heard about it, and they said that, they'd heard a Cypher Education talk at this conference in Berkeley. And he's like, are you now the one-woman hype show for Cypher NumPy? And I kind of am. So one of the things that Cypher Education really tries to do is promote that very unique capability that we have through Cypher NumPy. So the Cypher Education Labs, as I mentioned, these are a very important part of how we try to be that first choice for computational chemistry, is that we provide a lot of pre-planned lab activities. Cypher Education really started in the with WebMO. If you're not familiar with WebMO, it is a graphical front end that lets you build molecules and set up calculations for all kinds of different quantum chemistry software. The original I guess it was the original Psi3 WebMO interface was debuted at the 2008 PsiCon. So I debuted it for the first time there. And for a long time, this is what Cypher Education was about. It was about this WebMO interface and making labs to do that. And we've since sort of strongly pivoted to labs that use Cypher NumPy. So these are labs that teach entirely within the context of a Jupyter notebook, where the entire assignment is given in Jupyter. It can be graded in Jupyter using Jupyter's grading tools. And it also is a key aspect of sort of teaching students to code within the context of chemistry. So when you're using the Jupyter Notebook interface, you of course have to have Python skills, and this is a very large movement in chemistry education right now, is teaching programming within the chemistry curriculum, and Cypher Education is definitely a big and important part of that. I'm not actually going to show you any of the labs today. I'm not going to pull up a Jupyter Notebook and show you any of our fantastic labs because we are devoting all of Saturday's meeting to Cypher Education programming. So on Saturday, you'll be able to hear some lightning talks from some of our contributors, and they really will pull up their Jupyter Notebooks and show you some of our newest, most exciting Cypher NumPy labs, but I am not going to do that today. If you want to check out our website in advance of the session on Saturday, you just go to the main PsiCode website, psicode.org, and then you click on Cypher Education in the upper right corner, and that will take you to our webpage. So again, Cypher Education kind of started as these Cypher Education labs that were using WebMO, and we've now very much pivoted to being a project that promotes Sci4 more generally and has labs that teach programming through computational chemistry. So right now we have 16 lab activities. As I said, you can access them by going to psycode.org and just clicking on Cypher Education in the upper right-hand corner, and that will take you to our website right here. All the labs are maintained on GitHub, so they are totally open source, and anyone can download them and anyone can contribute to them. Since we do have a lot of people who use these in curricular contexts, like they use them as assignments in their classes, we distribute the instructor resources with all the answers through a private GitHub repo so that only instructors will have access to those resources. As I said, the Cypher Education Lab was sort of originally, we started releasing them in summer 2014, and we did a major overhaul this past summer to really pivot to doing more of these Cypher NumPy Jupyter Notebook labs. And again, I know that you're very upset that I'm not showing you any of these fantastic labs, but that is what we will be doing on Saturday. So I hope that you will join us then. These are some things that Cypher Education has done to try to increase the visibility of Psi4 over the last little bit. Again, this is not really increasing the visibility of Psi4 within the quantum chemistry community. This is trying to tell the larger chemical education community about Psi4 and how it can help them. So on the left here, I have some things that we've done in the past. We had a workshop at the biannual conference on chemical education, which is called BCCE. We had a workshop there in 2014, which was a hands-on workshop where we taught people how to use Psi4. We published our first publication about Psi4 in an ACS Symposium Series book in 2015. Members of the Cypher Education team have done numerous conference presentations over the years, and then I did sort of a hype workshop for Cypher NumPy at the Advanced Potential Energy Surfaces workshop in Berkeley last summer. Some things that we've done very recently and some future things over here on the right. There's a consortium called Enhancing Science Courses Through Integrating Python. They call themselves eSkip. And this originated out of the Cottrell Scholars community, and they actually invited me to be their keynote speaker for their conference this past summer. And they invited me because Daniel Crawford recommended me, so that was outstanding. And this really gave me an opportunity to promote some of the Molecular Science Software Institute's resources, as well as some of our Cypher Education resources. So this really presented our content to people who were very, very interested in it. There's a new ACS Symposium Series book coming out, teaching programming across the chemistry curriculum that focuses on teaching programming. And we're going to have a chapter in that book as well to talk about how we use the Cypher NumPy library to teach concepts in chemistry while also teaching programming. We're going to try to have a workshop at that biannual conference on chemical education in 2020. And then the most significant thing that I wanted to conclude with here today is our new partnership with Chem Compute. So Chem Compute, if you're not familiar with Chem Compute, you can check out their website at chemcompute.org. And the reason that we formed this partnership with Chem Compute is that whenever I talk about Cypher Education, every single time people are like, well, how can I get this on my campus? Because I don't have any computing resources. I don't have an IT person to even help me set up computer resources. And even as user-friendly as Psi4 is to install, some people's students don't have personal computers. Like, they cannot install Conda and install Psi4 on their personal computers because they don't have them. So I was actually talking at a conference with some of our community college faculty in the California community college system, and one of them finally told me to my face, they're like, Ashley, any computer barrier is too high of a barrier. There can be no systems administration, there can be no overhead, or we just can't use these resources. So this sort of, I think I've finally found the solution here with Chem Compute, because Chem Compute, as I said, you can check out their website here. Their entire goal is to provide entirely free online resources to help people use computational chemistry tools in their classroom. And they purposefully want to remove all computational, all systems administration overhead, all the installing, configuring, and maintaining of resources. They take that on so that literally all your students need is to set up a free account and have a web browser on their computer. So if you have computer labs on your campus, you can just have the students use Chem Compute from those computers. Another great thing about Chem Compute is you don't have to, ask permission or get approved or write a grant. Any person can have their class sign up on Chem Compute for free resources today. You just go to chemcompute.org. So I worked with the Chem Compute team this year. Mark Perry, who's one of my CSU colleagues at Sonoma State, is the director of Chem Compute. And I worked with Mark to get a Psi4 environment set up within Chem Compute. So this bad screenshot on the left side of your screen here is the Chem Compute website. And you can see that there is now a Psi4 Jupyter tab here at the top. And anyone who signs up for a Chem Compute account immediately has access to Psi4 through Jupyter. And if you clicked on that button, if you clicked where it says Psi4 Jupyter on the website, then it would start your virtual machine right there within your browser. And every single person who sets up a Chem Compute account immediately has all of our Cypher Education labs immediately provided to them through Chem Compute. And if you then clicked on that Cypher Education folder, here you would see all of our lab activities, and you could click on any one of these and directly start the Jupyter Notebook, and the students could start typing their answers in right away and running code. So I think this partnership with Chem Compute is finally going to give us the accessibility that we've really been seeking in Psi4 for a long time. And this Cypher Education folder actually appears in everyone's virtual machine. It is pulled from GitHub. So these are also always up to date. So they're always up to date. They're always the most complete versions. And if we need to update the Psi4 environment for everyone on Chem Compute, then I can work with Mark to do that. One other thing that I wanted to mention are some of, again, mostly for new people who haven't worked with Cypher Education before, are the outstanding resources from the Molecular Sciences Software Institute. I work closely with the Molsi. I'm a faculty associate with the Molsi. And we do not in Cypher Education, and we'll talk about this more on Saturday when we're talking about how to contribute a Cypher Education lab. But the Cypher Education labs assume a certain set of Python prerequisite knowledge. And we do not offer resources to teach Python because we think the Molsi already does that better. So the Molsi, I've put their education website right here. The Python data and scripting workshop is the workshop that we recommend to all of our users to develop those prerequisite Python skills that are required for doing our Cypher Education labs. And then this is actually another workshop that the Molsi has called Quantum Mechanical Tools that teaches people how to do some of the basic operations in quantum chemistry. It teaches them what a geometry optimization is, what a potential energy surface scan is, and it actually uses Psi4 through the Jupyter Notebook to do those examples. So we do have some exposure here in the Molsi educational resources. Again, if you're not familiar with the Molsi educational resources, I would highly recommend that you check them out. The Molsi education program is led by the fantastic Jessica Nash, who's a software scientist and the education lead at the Molsi. I believe she might be in the meeting today. She was a little bit earlier, so you can actually ask her questions if you have more questions about the resources from Molsi, which are very important for supporting the Cypher education resources. So how can you get involved if you think Cypher Education sounds fantastic? The number one thing that you could do is that you could write a new lab. Anyone can contribute a new lab. On Saturday in our Cypher Education session, Dom Siriani is actually going to go over sort of the process for contributing a new lab. He's going to show you the structure of the GitHubs and how you download the template and some very logistical things that you would need to know to contribute a new lab. He'll talk about sort of the vetting process and how we, how we check the labs and the processes that we go through before they're officially integrated as Cypher Education resources. One thing that I would remind you of is that if you are a core developer and you're developing a new feature in Psi4, a great way to get the word out about your feature is to write a new lab about it and then have the whole Cypher Education community see it. And this is, for example, what Ben Payton has done, who's been working on machine learning things in Psi4, and he has a great lab about using machine learning in computational chemistry that he's going to talk to you about and show you on Saturday. You can host a workshop or presentation. I'm happy to come talk about Psi4 and Cypher Education in almost any venue. So if you know of a conference or a workshop or another venue where it would be appropriate to have a presentation about Cypher Education, we want to be in all of those venues. You, of course, can give workshops and presentations, particularly as you become more involved in Cypher Education. And then, of course, everybody in the whole Psi4 community, we ask them to promote Cypher Education wherever you can on your own campus and in your own network.